Greetings, this is Artie from Artifact Electronics. So I recently picked up this vintage computer. I was going to make you guess to see what it is, but I guess the title's going to give it away. It's an OSI Challenger 1P, 6502 based with 8K. And it pretty much came like this. It was in pieces. Came in 3 boxes, the computer and a bunch of other stuff. So this is called the Super Board, because Ohio Scientific made a single board computer and then they decided to make the PCB a little bigger and put a keyboard on it. And then they put it all in a case. There's the top of it. And make a fully contained home computer out of this thing. This is my only means of loading existing software into it right now. And I've spent some time on this, and I'll tell you what I've done to it. There surprisingly haven't been any electrical repairs. It's pretty much so far only been of a physical nature, but it came with a whole bunch of other stuff. So there was a whole bunch of paperwork included in here, starting with some the vintage 6502 book, the 5th book, which was a bunch of applications for the computer, the original MOS technology hardware manual. And notice that it doesn't even say what it is a hardware manual for. It's for the 6502. There. Well, it's for the MCS 6500 series. So there's a hardware manual. There's a programming manual. And then there's a bunch of Ohio Scientific manuals. Which are kind of useful. There's schematics in there and all sorts of other stuff. A bunch of 3-ring binders, which have a lot of information on some more of the stuff I got. And I've kind of looked through this stuff briefly, and I'm really thankful this was included, because otherwise I wouldn't know what to do with a lot of the other stuff I got. So there's a memory expansion board with 8K of a static RAM on it, 2114s, and plugs into the main board using a 40-pin connector, and it needs power. It should be fun to power and test. The computer has 8K built in. And there was another box. Now, who of you lived in the LA area in the early 80s and remember Priority 1 Electronics? It used to be my hangout. So then we opened this box, and there's just stuff. Connectors. This one had me intrigued. It's an EEPROM programmer. Home built. Cables. A different monitor ROM. Different than the one that's in it. Here's a really neat addition. Replacement key switches for the keyboard. These should be total non-obtainium. And then I guess they made an S100 bus-like expansion for the OSI. And so this is like the backplane for it. That has this large connector. And here's one of the boards that you would plug into the back plane. Not sure what this one does yet. another backplane, more connectors, and I guess what this is a brand new backplane, or oh, very descriptive. I'm not sure if this is a backplane or just a proto board, but yes, we shall find out what this is. But that's not all. It also came with this home-built front panel, Altair style, that shows the address. It has LEDs for the addresses and the data. And I guess you can single step with this. You can set breakpoints or traps, as they put it, with a, you dial in the address with this thing. It plugs into the backplane I showed you earlier with this card. Then we have another plug-in. It's this thing. Also has a backplane board. And at first I had no idea what this was good for, but then I noticed that that's how you hook the EEPROM programmer up. And I guess that's how you build all of your neat stuff. So why they didn't just put it on one of those plug-in boards, I don't know. That would have made more sense. But I guess this makes it a little more accessible with the ZIF socket and everything. And other than that, a bunch of cables. This should come in handy, a 40-pin, a dual 40-pin connector. And the infamous Super R mod, which was the modulator if you wanted to hook up your computer to television set. A lot of Apples had these in there, and I guess this one was used on this computer to show it on it, to use a TV as a display. And that kind of sums up, here's the bottom of the case. And that does sum up all of the items I got in this Ohio Scientific grab bag I picked up. No, I lied. That wasn't all. Came with about 30 cassette tapes with games and utilities, assemblers, disassemblers, and all that sort of stuff. And that's going to give us hours and hours of enjoyment in finding out what this machine can really do. Now, I don't know how long this episode's going to be. Most likely I won't be able to stuff all of this info into one episode. But let's go ahead and at least play with the machine itself and see what we can do with it. And then we shall continue with using all those neat accessories we just had a look at. And take it from there. So sorry about the annoying cricket sound that I just heard. But I promised them some food if they would keep quiet, and I think it worked. So let's enjoy the peace and quiet till they realize I fooled them and they start up again. So the reason why this came in pieces was the motherboard fits in here. You can see the cutout for the keyboard and stuff. But originally the power supply, which is just a 3 amp 5 volt linear supply, was mounted on this plate. Now the problem with this plate was that, it could be hooked up through your wires, but you couldn't fit the computer and the power supply in the case. there wasn't enough space on the side. If you look, there's a little cutout over there, and that wasn't nearly big enough to let you mount this power supply alongside the logic board, which I guess definitely means that this was probably an upgraded power supply. Just a transformer, regulator board, and 2 big capacitors, but that had to be changed. So what I did was I cut an aluminum plate, and the reason I cut it this big was I didn't want to have to drill any additional holes in the case, and by drilling it this size I was able to utilize existing holes and just bolt it down. And then I just moved all of the power supply components and bolted them down to that plate, and now it'll all fit into the case and I can put the bottom on instead of having a spider web of connections. It looks like a real vintage computer, which we'll see soon. This board is pretty heavily modified, as you can see. I mean, it's somewhat documented in some of those 3-ring binders I showed you, but this was kind of scary. This is a 10-position. I guess it's a dual pole or a triple pole 10-throw switch. That gives you a lot of possibilities. Yes, I was tempted. I mean, look at all the mods on here. I was really tempted to say, let's start with a clean slate. Let's tear it all out and make this look like the schematics, but I didn't do that. Because looking at all the stuff that came with it, somebody used this. And I have a hard time believing that this was not working at some point in time. But for the best view, look at these mods. I mean, the point is, if I had removed these mods, I would have never been able to put them back again, I'm sure. So I left things in and said, let's test things the way they are and see what gives. So for testing this beast, I had a monitor I picked up for a few bucks a while ago, and it was languishing in the garage. But it does have has composite video inputs, and I figured, hey, good time to test this. Oh, a couple more things. There was a cutout for the fan in the back, which was non-existent. And there's a connector here that connects to these 3 RCA jacks in the back. And that was kind of mangled, so I redid this one. Cleaned it up a bit, plugs into the main board, and brings out video, cassette in, and cassette out. And that's really the only changes I've made so far. And then finally, time comes to see this guy boots up. So okay, I waited, and we flipped the switch, and got a screen of garbage. So this is the usual. I've seen this on TRS-80s a lot. If this happens, what it usually means is that the video circuitry in here is functioning, but the processor isn't coming up to initialize screen memory and everything. And there's no dedicated video chip, but it's all made out of discretes. Kind of like the TRS-80 again, but they were much more economical on this one. But I did some poking around and couldn't really find anything, and then finally I said, okay, let me look at the manual. Maybe the manual will tell me something about it. And it turns out that that was a wise choice, because this is the way that OSIs come up. They're basically sitting there in Never Never Land, or, you know, just looping forever. And what you're supposed to do is hit the brake key. So basically what happens here is it gives you a choice of what you want to do. D is for disk, C is for cold start, W is for, I don't know, I'm sure somebody in the audience knows, or I could go look it up. Oh no, W is for warm start, and M is for monitor. Disk, cold start, warm start, and monitor. So when we hit C for cold start, we go into basic. And there you go. And again, checking the manual, it's actually showing the right number of free bytes. So the memory is good on this. And it seems to be functional. So I thought, you know, hey, let's do the standard test. Oh, one thing that I also read is you always have to have the shift lock depressed, because if you type anything in lowercase, it doesn't recognize it and gives you errors. Microsoft Basic, and there you go. So at this point, great. I have lots of books with lots of listings and stuff like that, but I really don't feel like sitting here and typing anything in. So then it came time to using some of the plethora of cassettes that was included, and seeing if I could load any of those. And that turned out to be a long effort, because at first I couldn't load anything off. I couldn't load anything off a cassette. I sat there and I started to troubleshoot the electronics, because I thought there was something wrong. So here's the audio input jack, and after some mild conditioning, it goes through an op amp that brings it up to 5-volt levels, buffers it, hits a one-shot, which drives a 74 LS74 flip-flop, and then that goes directly into 6850 serial chip into the RX input. Not a whole lot that can go wrong here, right? So I played the tape, and I basically checked the path, the sound path, and you know what? It worked. It worked just fine. I couldn't find anything wrong with it. So I'll spare you the long sob story, but it turns out that there is a pot over here that adjusts the pulse width of when a new data bit comes in. And another thing is that these unmodified used to deal with 110 baud speed on the cassettes. Now, part of that monstrous mod I showed you will actually let you select 110, 300, or 600 baud, and some other stuff that I don't know, because remember, it was a 10-position switch, but only the first 3 are used. And I measured the clocks, did some calculation, and it turns out, also seeing some notes in the schematics, that basically the first position put the whole thing into 300 baud. Of course, I had it in the very first position for 110 baud, so I happily switched to the first position, and nothing happened. Well, no, that's not true. Something did happen, but it was basically garbage. A lot of garbage showed up on the screen, and that was about it. So after looking through the manual again, there's an adjustment procedure to set the pulse width over here for the one shot, and that is different for 110, 300, or 600, or whatever you're using. And it gave you instructions to adjust it between 500 microseconds to 620 microseconds, but that, I guess, was for 110 baud. So after looking at it, I figured, why not do it live? And the way that works is, unlike the TRS-80, when you're loading a cassette player on the cassette program from the TRS-80, it has two asterisks up here that blink on and off. And if it gets a checksum error or anything like that, it'll just stop blinking. And that's your indication that the tape load was bad. This one's interesting because when you load something off tape, it basically treats it as a serial stream of text. It's like you're typing the program in. So line number, command, ended by a return, and that's how it enters things into this machine. So what I did was basically I ran a few cassettes, looked at all the garbage flowing across the screen, and then started to adjust the pulse width using this. And I adjusted the pulse width till I started seeing something on the screen that looked like basic. And that was all it took. So let's do that. This package did not include a cassette player. And that is significant in that usually people would go through 1 or 2 or 3 different cassette players before they found something that worked right with their computer. In this case, unfortunately, that's not what came with it, so there were some more unknowns here, but this is a Tandy cassette player made for the later generation TRS-80s, and figured we'd give that a try. What we have here is darts and balloons. It's rewound. I reset the machine, cold started it, and here's what you need to do. You need to say load, start the tape, and hit return. Basically everything it reads shows up on the screen. So it shows up some garbage, which is probably some of the leader stuff. I mean, I was sitting there trying to debug that and see why it's doing that, but you have some patience, and you can see it's loading. It's essentially pretending like I'm typing this in really fast. And, you know, the way you type in basic stuff is you type a line number and then the command itself, and that's what it's doing. And this is probably going to take a while. So, break time. I hope you had yourself a nice break. This took over 3 minutes to load. Seemed to have done okay, so let's see if it runs. Change to 24 by... This is already running in 24 by 24 mode, but let's say yes anyway. Darts and balloons. Press escape to start. No instructions, so... Alright, we're generating a maze with dots. Well, oh, I guess I'm in the balloon up here. How do I move? Okay, 4 is right, 3 is left. Two is down and 1 is up. So I guess I'm supposed to eat as many dots. Oh. This is very nice. Anyway, you get the idea. I'm going to have to look at the code and see what kind of an algorithm it uses for running the maze. It's nothing, it's not like Lee's algorithm or anything. I think he's just like trying to make left turns. Yep. No, then he made a right turn. I don't know. But there you go. We were able to load off of the cassette, and I got 84 points. So one other thing I tried was obviously loading off the cassette. I now got the volume figured out and everything, but probably be nice to have a more permanent way of saving this. So once I loaded the game, I hooked it up to the digital recorder, and I actually saved it out to the digital recorder. I tried it both with WAV files and MP3 files, and again I had to find the proper levels both for recording as well as for playback here, but once you find those, it works very well. So maybe I'll archive all of those things on MP3s. And then maybe I won't. But what we're going to do now is, since things seem to work, let's go ahead and put this thing back into its case now that it'll fit next to the power supply, and see it in its full glory. Well, before putting things back together again, I realized that there's a 40-pin socket under here. That is the general expansion connector. And once this board is mounted in the case, with the chips facing this way, and it being screwed in, access to this socket is near impossible, especially when you put the bottom on. So I figured let's try out some of the goodies that came with it while we're still sitting on the bench. So the first thing I took was this memory board, and I did some checking. This is like a cheap version of the OSI 610 board, which has like 12 or 16K of RAM on it, and also has a PIA and a connector, so that's how you connect floppy drives to it. But I guess this was a third-party one. It just says Dr. Bob on it. There's no other identification, but this has 8K of static RAM, all of the decoding required, and also the PIA 6821. And I guess if you had a disk drive, you connected it through here. So what I did was, it comes with this 40-pin cable that connects to the expansion connector. I observed polarity and everything on it, gave it a separate power supply, powered it off of my desktop supply, and nothing happened. The computer steadfastly ignored the memory board. So after looking through schematics and everything, I noticed that in order to talk through the data lines on the expansion port, it goes through these two chips, and these two chips were not present. The sockets were there, but nothing was plugged in. And what those are AT28 4-bit bidirectional buffers, and I guess whatever you didn't need immediately on this board wasn't plugged in. Now, AT28s are not easy to come by. They do pop up on eBay, but that didn't help me because I wanted to see if this board was going to work. So I basically cannibalized some of the other boards I got, and I found two AT28s, and I plugged them in here. And things seem to work better. So the first thing we do is let's power up and see how much memory this sees. So it sees 7423 bytes. And the difference between that and 8192, which is the full 8K, is, I guess that's paying off the middleman, in this case the operating system, or BASIC, I guess, which uses some of that data. So then next, I'm going to turn this off, powered on the HP, and what I did with that is power the expansion board with this. Notice that I got the output voltage set to about 5.2 because in my cable setup there was quite a bit of loss. But I bumped it up and now I got good voltage on the RAM board. So then we go back and see if the machine actually sees the extra 8K. And there you go. It sees 15615, and if you subtract 7423 for that, you end up with 8192, which is exactly 8K. So it looks like the 8K board's running. It's consuming about, 0.83 amps. Since this is consuming almost 2 amps, I could probably wire everything together from this power supply, which is a 3 amp, but on average it would, take upward of 2.8 amps for both of the boards, so that's probably not a good idea. If I wanted to power them off of the same supply, I should probably put like a 4 amp switcher in here, and then that would work, but, for now, things work. I did find a cassette that was labeled mem test, but it didn't load. So just the fact that PowerUp sees the memory would lead me to believe that it is functional. And when I get a disk drive for it, then we'll see if the rest of the circuitry also works. Next we're going to have a look at the front panel debugger, whatever this is supposed to be. And I didn't really have any schematic info on this. There was some hand-drawn things and notes and stuff like that, but nothing really explained how to do this. So I did a lot of measurements, continuity measurements, checked that the grounds were common, that the powers weren't connected, and stuff like that. It is powered separately, so I'm using the same power setup I used for the memory board. So the way it goes is we come out of the expansion connector on the motherboard, and we go into a control card that plugs into the back plane. And then there's another card over here that comes out of the debugger, or the front panel, and that goes into the back plane. So I guess that's how they would communicate. As you can see, there's a good amount of stuff in there. There is a chip missing right here, and I have no idea what that's supposed to be and if it's necessary or not. But let's power this thing up and see what it does. Okay, so we power up the front panel. Same thing again, I got the voltage set a bit higher, so we get a good 5 volts. And we are not getting the 5, because I guess it's drawing more current. It's limited to 1 amp. So let's go to current and bump that to 1.5. And so it's drawing about, what, 1.15 amps, and the voltage comes up at this point. So this thing's powered up. Some of the lights are on. Well, there's no activity, then that's because the CPU board is not up yet. So let's turn on the CPU board and the monitor. Hello. Okay. Alright, so at least the board seems to power up. That's good. So the computer's running now. The light show has changed a little bit, but this should be, well, okay, so there's a run switch here. Put that up, things light up, but I really don't see things flickering over here. I don't think it's showing us what's actually happening. And you try, there's a, so we can, let's see, the trap is off, it's on run, so we can halt it, and then single step it, nothing happens, reset it and nothing happens. Oh, another single step over here that does make the lights change a little bit, but I don't think this is working right now. But it gives you the idea, you know, if it was working, you'd have an Altair front panel with the lights blinking, showing you the address and data bus in real time, and, you know, you could set a breakpoint through the thumb wheels over here and trap things there. And bottom line is this is going to take, I think, quite a bit more research on my part. I mean, I basically got to partially reverse engineer this to look at the signal path and try to figure out why, you know, what I've forgotten to hook up. I mean, there's trigger inputs over here too. And doesn't make a difference. So, you know, is it a bad connection? There is a missing chip inside here. I'd have to look it up. There's also this monstrous connector that goes to the back plane, and the blue and red wires there are just power duplicated, and I have no idea what the other fat cables are. But I would think that I'd have to figure out what all of those are and where they're supposed to go before even attempting to make, I mean, or even expecting this thing to work. But would be kind of nice to have schematics for what's in here, and I'll look through some more of the paperwork. But hey, just thought I'd show this to you. It's not a super helpful thing, But it still looks kind of neat. Would be cool if the lights blink, but hey, when we get to it, we get to it. Well, here she is, all put back together again. And what we have here is, well, she's just back in the case. The power supply fit, didn't short against anything. Those wires, those switches that were connected to all the mod wires have been mounted in front, and there were holes here, so they were in here at one point in time. Baud rate selection. So most of the cassettes I had were 300 baud, but I guess older ones are 110, and you could also save things out at 600 baud for a quicker loading time, I guess. And there's a switch on the inside where you can hook up a terminal to it and communicate with it with 600 baud, I guess. And I haven't really dealt with the other 8 or 7 positions on the switch, which seem to be different baud rates, but that is not going to happen this time. The other switch is it inverts the screen. Doesn't work too well on this monitor, so it's supposed to be black on white. But yeah, and while we're looking at this, it's basically loading the ultimate game, and I don't know how long that's going to take, but let's see, what else can I tell you about it? Not much. It works. It's a 1P, it's a modified 1P, and another true piece of computing history. So let's wait and see for this thing, see if this thing will actually load. So it took a while, but looks like it loaded, and we have 250 bytes of memory left over. But before we run this, a bit of old business. Remember we did a review of the $5 tester. I got a few comments on it, but one of the more interesting ones was somebody commented that they liked the tester, but they hated the fact that the battery was flopping around. I guess he didn't get a case either, and was kind of unruly to use it. So what he told me was that he went to the dollar store and bought some Legos and built a little bit of a holder for it. I thought that was a great idea, so off to the dollar store I went, and $2 later, and a few minutes later, here's what I ended up with. Got a base plate and a bag of blue Legos, and look Ma, no flopping, no nothing. It's even got a little stand on the back that I guess you could extend if you want to tilt it more. But yeah, thank you for that suggestion, and it makes this an even better pleasure to use than it was before. But back to the game, what we just loaded here. Yeah, we're sitting at 250 bytes free, so let's see. Remember, this has 8K. You want instructions? Yes. And it doesn't really identify the game, but you know, to resupply the Enterprise you must dock at a starbase, so we all know what this is. So it tells us how to play and so on and so forth. And it wants a random number. And then it works. And there you go. A truly interactive game. A truly interactive Star Trek game. See, now I said it. So, yeah, one day we'll sit down and figure this out together and have a great time playing Star Trek and resupplying. But until then, I hope you enjoyed this. A true piece of computing history. Make sure you like, make sure you subscribe, and make double sure you leave me a comment. Thanks, and happy computing.